Hi everyone, Giza Brains and everyone here. I'm Adidin Sophia Burger for Giza-action. Present to you forecasting, pool forecasting here, pool volume forecasting. And in my project, before I go into the forecasting, I actually worked on the yen data set from Giza. On the yen data set, and the reason why I did not take that project to the very end is because I got results that were not too encouraging. Let me draw this down. Yes, now me using, I think it was after processing the features or the columns. Yeah, I was getting quite usable and I go for this particular model. And this was just basic model. It's like you recall this one. It was quite good. It looks quite good for prediction. But when I decided to check for the loss function and use it with ensemble method, I was just take a look at the loss. The rate at which data are being lost. So it's quite a shock where I see this here and it looks promising, and I then checked it and what's going on. And in my dashboard, let's go to the appointment. Over here. Yeah, this one, the last one that passed. It's quite a beautiful model. I wish it had actually worked, if not for the loss, the data loss that I was seeing, the loss, which was the loss function was so high. This could have been the very best. So we prepared the data set. From preparing the data set, we create a loader. So from that loader, the loader then sends data for the model to be trained. The same loader also sends data we also test the model, and it's also loading for the evaluate ensemble and both the evaluate ensemble here. And from the train model, you convert to ONNX, and from the train model also, okay, yes, you also test the model, evaluate with ensemble, which would have been beautiful. So this yen data that I was working on was to detect anomaly in deposits. So basically what I was trying to do here was to detect the anomaly in deposit of when you are depositing USDT. Check but the R loss function was quite so high. I don't know. I don't think it's quite encouraging to use it, although it makes a very beautiful model when I look at it all together. Then back to my code again. Yeah, now let's talk about pool. My project description. So we're forecasting pool volumes using time series data. It begins with loading data from polar into data frame, extracting relevant features such as day, week. I have where is it? Here, my pool note. So let me drag it to the top. So first we install the dependencies that we need. Where I load the data, balance, daily trade volume. Then begin by extracting it from the polar data frame. We convert it to pandas. This is we inspect the data to see what's there. You can see that there are even token pairs sort to weight, front to USDC to weight, and just like that. And when I check for missing values, there were no missing values. and the distribution of trading volume, which looks quite good. And yeah, so we perform one hot encoding for categorical variables, which were the blockchain and then token pair. Yeah, so we perform all this the token pair and the blockchain, all this blockchain, one hot encoding. And then we also used standard scalar. Yeah. So I actually put for both mean max scalar and standard scalar, where I decided to go with standard scaling, yeah, to normalize our data. And after the normalization, we also convert the day column to date format, day of the week, month, year. I found the correlation. The correlation between this data initially was not so good. We're getting negative values, so obviously we are going to need more features and quite an advanced model to help us to see if we could predict a very good data. So yeah, box plot, which looks quite nice. So this for days of the week, and for months, and trade volumes for years, for year 2022, 2021. Because 2020 is quite low. That was during the COVID time. 2021, 2022, and see even 2024, which is quite slow since the year is not far gone. And this is just more of the data. Check again the missing values. Then we split it into train and test, train and validation. Okay. Yes. So and we prepare the data for it to be loaded because we're using a data loader. So which means we had to set a window and convert the list to numpy array. It's just to this process that we're doing here is just to make sure that our data it actually fits with what the model expects, and it doesn't cause conflict. And part of reshaping it, we also had to reshape it. Since these two are not of the same shape, so we had to reshape it. So this target, so it will be with the input and target will have close to the same shape. I'm going to just get that now. I have to run the entire notebook again, but let's move on. Okay, we are inspecting the data. And I use WaveNet, which is from TensorFlow. The tutorials that I used, most of them are based on PyTorch and the neural net. So this is also a neural net, but this is using WaveNet. Yeah, this is the data generator where we then use the sequence input and the sequence target. And our model, this is where we define our model. Although here you see I have two different functions, but I had to refit it for this chain action. It had to be fitted so the function, because since in a task we cannot call a function in a task, we can only call a function in an action. So I combine both functions together here. Let's go out to the notebook. Here we define the window, number of filter, block, kernel, number of classes, and here we have a model. Although it it's not like the what they call it, the yen that gave quite up to trillions. the loss for the loss function. But the loss here is also quite high as 0.9995. It means this model is not quite training well, although it's still fair. It's better off than the previous I worked with, but it's still fair. So I had to terminate it. Yeah. And even here, I used epochs of 30. Epochs of 30, that's okay. Where is the epochs of 30 is not something you want to run because of it uses quite a lot of memory. As I wanted to run with epochs of 30 on using the action, but it was taking it took almost 3 hours and it was not even done. So I stopped it and just went with one epoch. So it's just for us to speed off our movement because the deadline is quite at hand. So let's see. Yeah, this is the one for pull. And here is our model. It doesn't look quite classy as the yen, but yeah, this one, since it gave us quite a better of loss function, so we're able to convert the model that we trained into ONNX. And I didn't include a test model outside here because it was inside this train model. The functions inside this train model in the action after training the model, I just include functions to also run the test, which was what we see here. Okay. What we see here, because the test loss and the test mean. Yeah, so the model to be able to test it, and I was able to convert it to CAIRO. So I wanted to deploy it also to both. Since after converting to CAIRO, I wanted to deploy it to both CAIRO and EZKL. Okay, I think I have a picture of it. To EZKL, but I had an error while changing to EZKL. While trying to get the job in EZKL. While for CAIRO, I'm still trying to get in the chat, so we can know how well our data actually behaves for predicting or forecasting pool volume. Although the market itself is fluctuating and is very, very unstable, so that the fact that our model didn't train well, it might be positive and also it might be negative. As for my inference. So thank you for joining me.